All right, we're looking at page 508. We're looking at surface area of pyramids and cones. If we look at this pyramid here, we have an edge of 10, or lateral edge of 10. So here we have a base of 12. It's a square pyramid, so here's our base, 12 by 12. And we have our height here, which we don't know. So determine the perimeter and area of the base. Well, if we have sides of 12, 12 plus 12 plus 12 plus 12 is 48 feet. Our area is 12 times 12, 144 feet squared. Make sure you're using the correct units, either linear, squared, or cubed when we're talking about volume. How can you determine the height of the triangular face? So here's this part, but let me draw, well actually, here is the whole lateral face. It's a triangle. So when we just draw that one part, half of the side is 6, the lateral edge is 10, so we use Pythagorean theorem, and this L is 8, or the height of the lateral face is 8. That is the slant height. The distance between the vertex to the perpendicular of the lateral face. So to find the area of the lateral face, it's just a triangle, so 1/2 face, 12, times height, 8, and that's 48 feet squared. The lateral area, well, there's 4 of those, so 4 times 48, 192 feet squared. What are we still missing? We're still missing the area of the base, which we found up here. We add those two up, 336 feet squared. So our lateral area is 1/2 the perimeter of the base, just like it was before, times our slant height. That's what L stands for. So the total formula of a pyramid is 1/2 the perimeter of the base times the slant height of the face plus the base area. There's only one base, so it's like our prism, but we only have one base. So if we look at a tetrahedron is a triangular pyramid. All faces are equilateral. So if we look at the base, and all the faces look the same, well, here it is. We have 8, and it's a 60, 60, 60 because it's equilateral. And we draw a perpendicular, it cuts that, so it's 4. So the slant height is 4√3. So 1/2 the perimeter, 8 plus 8 plus 8, 24 of the base, times the slant height, which is 4√3, so of the lateral face, which happens to be the same for this, but that's not what we're talking about. This is our base, and this is the lateral face, plus the base area. So the base area is just s squared √3 over 4, 8 squared √3 over 4, 64 √3 over 4, which is 16 √3. So when we add all that up, we get a surface area of 64 √3, or 110.9 feet squared. Answering some questions, name the shapes of the lateral faces of a regular pyramid. They're isosceles triangles, always. Can a pyramid have quadrilaterals for lateral faces? No, because they would not have one common point of intersection, or our vertex. They wouldn't come to a point. They would come to a base, just like where they're coming from, so it would be a prism. Each side of the base of a square pyramid is 5 feet. The slant height of the pyramid is 4 feet. So here is our pyramid, square base with 5. Our slant height, so the height of this triangular face is 4. Calculate the lateral area. Well, it's 1/2 the perimeter of the base times the slant height. So 5 plus 5 plus 5 plus 5 is our perimeter, 20, times our slant height, 4, times 1/2, so we have 40 feet squared. Our surface area, well, we have to add on to our base area. Area of the base is a square, so 5 times 5 is 25, so 65 feet squared. The slant height of the pyramid is double, and the dimensions of the base remain the same to create a new pyramid. Describe how the change in dimension affects the lateral area of the pyramid. So it was 40, 1/2 20 times 4, and now we double the slant height, now it's 8, so it turns into 80, it doubles the lateral area. So we double the slant height, we double the lateral area. Number 7, we're looking at a regular tetrahedron again. So 4 triangular faces. Calculate its lateral area. Easiest way to do it, there are 3 equilateral triangles, so 3 times our formula for equilateral triangle, s squared root 3 over 4, with an edge of 12. So 3 times 12 squared root 3 over 4 gives us 108 root 3, or each equilateral face by itself is 36 root 3. So 3 of those gives me that. And we add on the base area, we add 1 more, and it's 144 root 3, or about 249 inches squared. All right, if we're looking at cones, remember the only difference between a pyramid and a cone is the base. In a pyramid, the base is a polygon. In a cone, the base is a circle. So if we look at the same formula, 1/2 the perimeter of the base, well, the perimeter of a base, when we're talking about circles, is actually circumference. So it's 1/2 2 pi r times L, but the 1/2 and the 2 cancel out, so we get pi r L. Then the base area of a cone, well, it's a circle, so it's pi r squared. So this is our formula. These are the 2 formulas for today. And we'll do one example here. The diameter of the base of a cone is 10 centimeters, so radius is 5. The slant height is 7 centimeters, L. Determine the lateral area, so it's pi r L, pi times the radius 5 times the lateral area of 7, slant height, so 35 pi, or about 109.9 centimeters. Our surface area is that plus the base area, which is the area of the circular base. So pi r squared, with r being 5, so 25 pi. Add those up, 60 pi, which is about 188.5 centimeters squared. So very simple, just use our formulas, don't do anything different. Our homework is page 512, numbers 14 through 18.